Okay, so finishing number 3, we had just taken our two delta D equations and subbed them into our equation that connected them. So now we have a t squared term in both, a t squared in both terms, so factor it out. So it becomes 1/2 a1 plus 1/2 a2 is equal to 100 meters. And now divide both sides by the bracket. So 100 meters divided by 1/2 a1 plus 1/2 a2. So 100 meters divided by 1/2, 1.5 meters per second squared plus 1/2, 1.2 meters per second. There's a point in there, squared. And that's going to be a t squared. You're then going to take the square root. Before the square root, I think it's 74.074. And that's repeating. With the square root, it's 8.6066 seconds. Okay, so that's how long it takes them to reach each other. And then the question wants to know how far have they each traveled. So you would then turn around, and for student 1, you would do delta D1, we had it was equal to A1 delta T squared. So 1/2, 1.5 meters per second squared by 8.6066 seconds squared. And for 2, it's 1/2 A2 delta T squared. So 1/2, it was 1.2 meters per second squared. 8.6066 seconds squared. When you do the top one, you get 55.5 repeating meters. And when you do the second one, you get 44.4 repeating meters. And when you add them together, lo and behold, they add up to 100 meters. So it means you did it right. All right, number 4. Says, student who is traveling 72 kilometers per hour in their truck decides to pass a second student. It passes a second student who is stopped. So VI, 72 kilometers per hour. And when you switch that, it's 20 meters per second. VI over here, 0. The second student accelerates to try to catch up, and they accelerate at a rate of 4 meters per second squared. The first student, just to make life more complicated, speeds up at a rate of 2 meters per second squared. How long before they catch up, and how far has each traveled? How long before they catch up will be the same. Actually, and how far have they each traveled will also be the same, because they're starting at one spot and they end up together. So delta D for the first student will be VI delta T plus 1/2 A1 delta T squared. And delta D for the second student will be VI delta T plus 1/2 A2 delta T squared. And this person's VI is 0. How are they connected? D1 should be equal to D2. Which means, filling it in, VI delta T plus 1/2 A1 delta T squared should be equal to 1/2 A2 delta T squared. I would divide everything by delta T to get rid of. So then you would have VI plus 1/2 A1 delta T is equal to 1/2 A2 delta T. Take your delta T's to the same side. So VI would equal 1/2 A2 delta T minus 1/2 A1 delta T. If you want, you could multiply both sides by 2, VI, and then I would factor the delta T out. So it would be A2 minus A1, and then divide by it. So 2 VI over A2 minus A1. So 2 times 20, that's about 40. Divided by 4 meters per second minus 2.2 meters per second. That's about 1.8 in their second squared. So 40 divided by 1.8, delta T should end up equaling 22.2 repeating seconds. Okay, That's the first part of the question. Second part wants to know how far have they each traveled. Okay, so to find out how far D2 has traveled, it's just going to be 1/2 A2 delta t squared. So 1/2 of 4, about 2, times 22.2 seconds, and the 2's repeating squared. Delta D2 has traveled 987.654. Oh, cool. If you keep all the numbers, it's 654,321 meters. Okay, delta D1 was VI delta T 1/2 A1 delta T squared. So delta D1 initially going 20 meters per second, 22.2 seconds, plus 1/2, 2.2 meters per second squared by 22.2 repeating seconds squared, and lo and behold, you get 987.654,321 meters again. Number 4, done. Number 5 is a person shooting a puck. Okay, so, and a person trying to stop it. And we'll just call this person a student. So the puck is initially given a velocity of, strikes a puck, initial velocity 20 meters per second. And it says the ice has just been cleaned, so it slows down. Its A is -1 meters per second squared. And it travels towards the net, which is 30 meters away. Okay? The student is standing there watching. So standing, VI is 0. And they're 5 meters away. But they don't want 5 meters. They don't want the puck to go in the net. So they're going to speed up at some rate to try to stop it, right? So the puck's traveling this way and the student's traveling this way. And they want to get to the spot at the same time, which means however long it takes the puck to travel, that's how long the student has to reach there. So if we can find the time for the puck, then we can use it and find the A for the student. Now if you use delta D is equal to VI delta T plus 1/2 A delta T squared here, you're going to get a quadratic. So I would suggest using, for the puck, VF squared equals VI squared plus 2A delta D first, and solve for the VF. So 20 meters per second squared plus 2 times -1 meters per second squared times 30 meters. So it's going to be 400 minus 60, 340, take the square root. The speed for the puck is 18.4391 meters per second. Because once you have this, then you can do A equals VF minus VI over delta T. So delta T is equal to VF minus VI over A to get your time. So 18.4391 meters per second minus 20 over -1. And you get a time of 1.560, paper moved, 609 seconds. Okay, and so that's the time for the student. So then go over here, delta D is equal to VI delta T, 1/2 A delta T squared. This goes to 0, so A is going to be 2 delta D over delta T, so 2 times 5 meters over, oops, that's a squared, over that 1.5609 seconds squared. And you end up getting an A of 4.1045 meters per second squared. Okay? So hopefully that one was pretty straightforward. So what would I assign next? I'd assign the next 3 on this sheet, 6, 7, and 8. And really that's going to be the end of kinematics. Once we did 6, 7, and 8, then I would hand you an assignment. And I would say try to do this assignment as if it was a test without looking back. And it has these 10 questions, or these 11 questions, sorry. And then these 3.